student. Today I am going to discuss about temperature coefficient on resistance as well as resistivity. Before I start about this one, I have discussed about what electrical resistance, resistivity, conductance as well as conductivity. So what do you mean by resistance? Already I have discussed. That is, what is resistance? Resistance means it is the property of conductor which obstruct the electric current whenever the current pass through it. That means what? Ar mane kono? That hela eta hochi ଗୋଟେ conductor property ଯିଏ କି କ'ଣ କରିବ ଅଧିକରୁ ଅଧିକ ପରିମାଣର କରେଣ୍ଟକୁ କ'ଣ କରିବ ଅପୋଜ କରିବ। ଅଧିକ ପରିମାଣ ମାନେ କ'ଣ? ଯେତିକି ଆମାଉଣ୍ଟର କରେଣ୍ଟ ଫ୍ଲୋ ହେବା କଥା ସେତିକି ଫ୍ଲୋ ହେବ ଗୋଟେ କଣ୍ଡକ୍ଟର ଦେଇକି। ଯଦି ଅଧିକ ଆମାଉଣ୍ଟର କରେଣ୍ଟ ଫ୍ଲୋ ହୁଏ ତାହେଲେ ସେ ତାକୁ obstruct କରିବ ବା ଅପୋଜ କରିବ। That means it is the net opposition offered by the conductor which oppose the current, which restrict the current when the current pass through it. That is called basic definition of resistance. Already I have discussed. Now I am going to discuss about electrical resistivity or resistivity. What is the basic definition of resistivity? So resistivity माने कौन? Okay. Resistivity means it is the property of a material. Resistance means it is the property of a conductor, but resistivity means it is the property of a material. Okay, which obstruct the electric current whenever the current pass through it. Sir, material कौन सेटा conductor कौन देखियो आमे सेटा हला. So resistivity means it is the property of material which restrict the electric current. Okay, or हमें कही परिबा कौन? It is the property of a material how to resist, how strongly resist the electric current. Or हमें लिख परिबा it is the property of material how strongly resist electric current. Clear? So this is the two definitions are there. जोटा तुमको इजी लागुची सेटा तुम लिखि परिबो. Okay, so it is the property of a material, it is the property of a material which resist or which restrict the electric current, or it is the property of material how strongly resist electric current. Okay, so this is the definition of resistivity. कंडक्टर रे जे भी करंट को अपोज करूची ताकू आज रेजिस्टेंस. कंडक्टर बदल रे हमें मटेरियल को जदी हमें नबा मटेरियल भी कंडक्टर ही परिबो. ओके, तार्थ मटेरियल रे जे की करंट रो प्रवाहित को से अपोज करूची. तार्थ कोन अपोज करूची इन द सेंस कोन अधिक परिमाण रो करंट गल अपोज करूची ताको कहबा रेजिस्टिविटी. तो हमें केमिति रेजिस्टेंस इक्वल टू रेजिस्टिविटी हमें रिप्रेजेंट करेगा ता देखिबा. वी नो R equal to rho L by A. If L equal to 1 meter, A equal to 1 meter square, then R equal to rho. So, if resistance said to be resistivity, if resistance is said to be resistivity, when the conductor whose length is 1 meter and area cross section is 1 meter square. Then the resistance of a conductor is equal to resistivity of that conductor or resistivity of that material. Okay, so in order to define resistance equal to resistivity, the resistance of a conductor is equal to resistivity of the material when length of conductor is 1 meter and area of cross section is 1 meter square. Then we have to represent resistance equal to resistivity. This means the resistance of a conductor is equal to resistivity of the material when the length of the conductor is 1 meter and area of cross section is 1 meter square. Okay. So next one is, please note it. After that I will erase that thing. Okay. Unit of resistivity. Unit. So R equal to rho L by A. That implies rho equal to RA by L. You know that already. I have repeated this. So R means ohm, meter square divided by meter. So that means rho equal to ohm into meter. This is the unit of resistivity. Okay. Now I will discuss about conductance. What? Conductance. What do you mean by conductance? Conductance. It is denoted by symbol G. Clear? So what do you mean by conductance? What do you mean by resistance? Resistance is the property of a given conductor whenever the current pass through it, so that it restricts the current in order to flow through it or in order to pass through it. So conductance means it is the property of a conductance in order to flow the electric current. What? Conductance is the property of a conductor in order to flow the electric current. In order to flow the electric current. So therefore resistance of the conductor, which is directly proportional to 1 by conductance. Okay. If you remove the proportionality, then we add a constant quantity or multiply a constant quantity, that is denoted by A into 1 by G. When A equal to 1 unit, then what will happen? Then A R equal to 1 by G. So resistance of a conductor is reciprocal to conductance of a conductor. Clear? So resistance, which is the reciprocal of conductance. Okay. resistance is the reciprocal of conductance in case of conductor. Okay, so unit of resistivity is ohm meter, and second thing is conductance. Conductance means conductance is the property of a conductor in order to flow the electric current, but resistance means resistance is the property of a conductor in order to restrict the electric current whenever the current pass through it. Okay, so resistance is directly proportional to 1 by G. That means R equal to, if you remove the proportionality, we will multiply a constant quantity that is denoted by A. If the constant quantity A equal to 1 unit, then R equal to 1 by G. That means resistance of a conductor is reciprocal to conductance of a conductor. Okay. Now I am going to discuss about unit of conductance. Clear? Unit of conductance. So that is bracket like here G. Okay. So unit. So resistance we know equal to 1 by conductance. That implies conductance equal to 1 by resistance. So unit conductance, that implies equal to 1 by ohm, or it also represents as a ohm inverse. Okay. So G unit is ohm inverse. Okay. Or mho or Siemens. Okay. Ohm inverse or mho or Siemens. Clear? So these are the three different unit of conductance. Ohm inverse because it is the reciprocal of, that is ohm inverse, or it is denoted as a mho, or it is denoted as a Siemens. Okay. So this is the unit of conductance. Clear? Clear? What is the dimension of that conductance? Dimension. How to calculate dimension? G equal to 1 by R. So that implies 1 by R. 1 by R means what? R equal to V by I. That implies I by V. Okay. I means what? That means dimension is, और हम लिख परिबा एम्पियर पर, और लिख परिबा एम्पियर, another unit is ampere per volt. This is the unit of conductance. Okay, so I is here, V means W by Q. Okay, so I into Q means what? IT. So W means what? Fs divided by IT. Clear? IT. That implies that is equal to I is here, and second thing is Fs. Okay, so the dimension of I is ampere divided by F means M1 L1 T minus 2. This is the dimension of force, and this is the dimension of displacement L1 divided by I means ampere. Okay, T means T1. Clear? So here what will happen? A is here. So A to power 1 is here, A to power 1 is here. That means A to power 2 is here. Okay. And this one is T1 is here. Now it is going to upper, so that is T1 is here. T1 is here. That means this one is M1, this one is L2, M1, L2, T minus 2 is here. So what will happen? G equal to M1, L2, T minus 2, that is T1. That means what will happen? That is T plus 3, that is M minus 1, L minus 2, T3, A2. So this is the opposite of conductance, this is the opposite of resistance. So this is the dimension formula, that is M minus 1, L minus 2, T3, A2 is here. Clear? Clear? Please note it. Now I am going to discuss about conductivity. Conductivity. You know resistivity? It is the property of a material which obstruct the electric current whenever the current pass through it. It is the property of material which flow the electric current inside the material, that is known as conductivity. So it is denoted by sigma. Clear? So conductivity means it is the property of a material which flow the electric current. Clear? So conductivity is directly proportional to 1 by resistivity. Okay, that means conductivity which is equal to 1 by resistivity, A into resistivity, where A is constant, its value is A is 1. A is constant, its value is 1. So sigma equal to 1 by rho. That means therefore conductivity is reciprocal of resistivity. Clear? Unit of conductivity. Unit of conductivity. What is the unit of conductivity? But sigma equal to 1 by resistivity, whose unit is ohm meter. Ohm meter, 1 by ohm meter. So while we going to upper or numerator, that means the conductivity is 1 by ohm meter. That means ohm inverse meter inverse. So this is the unit of conductivity. This is the unit of conductivity. Clear? Clear? This is the unit of conductivity. I have discussed about unit of conductivity, but your homework is dimension of conductivity. Your homework is to find the dimension of conductivity. तम पई काम होला तमे डायमेंशन काढियो कार कंडक्टिविटी रो डायमेंशन काढियो मते आनी देखे. ओके, प्लीज नोट इट. ओके, this is your homework. Dimension of conductivity you have to solve. Clear? Please note it. Now I am going to discuss about main topic, that is temperature coefficient on resistance or resistivity. Temperature coefficient on resistance as well as resistivity. Clear? I have to solve that is. So what do you mean by temperature coefficient? It is denoted by alpha. What? Temperature coefficient is denoted by alpha. Okay, so as you know that in order to maintain the temperature, that means at constant temperature, in case of conductor, resistance as well as resistivity becomes increases. You know that thing. Clear? But in case of semiconductor, if you increase the temperature, resistance as well as resistivity becomes decreases. But in case of alloy, what will happen? There is no effect of resistance as well as resistivity if you increase the temperature. So these are the three basic conditions. Using that three basic conditions, I have solved the temperature coefficient or find out the temperature coefficient in case of resistance as well as resistivity. So here we know that at a constant temperature, what will happen? At a constant temperature, the conductor whose initial resistance is R naught. Here we write at constant temperature. Clear? At constant temperature, the resistance of given conductor is R naught. Okay. In order to increase the temperature, then in order to increase the temperature, from T to T plus dt, then initial resistance becomes increases from R naught to R naught plus dr. Is it clear, play? So जेतबेले हमें at constant temperature रखिबा गोटे resistance रे सेतबेले हमर initial resistance केते थाए R naught थाए. Clear? This is the R naught. जेतबेले हमें increase करिया temperature सेतबेले कार increase होला temperature टा गोटे conductor ता केते केते T रू T plus dt को जेतबेले हमें increase कले temperature को सेतबेले जो कंडक्टर रे जे रेजिस्टेंस थिला केते थिला R naught थिला से केते चेंज हे गेला R naught रो R naught plus dr चेंज होला. Clear? Okay, that means the change of resistance, that is the change, this is the change of resistance depends upon two factors. What? Therefore the change of resistance is directly proportional to initial resistance as well as change of temperature. Clear? That is dr, that is change of resistance dr, which is directly proportional to what? That is called what? R naught and dt. So change of resistance is directly proportional to R naught and change of resistance directly proportional to dt. That implies dr directly proportional to R naught into dt. Clear? If you remove the proportionality, then we have used a constant quantity dr equal to, if you use a constant quantity that is denoted by alpha into R naught dt. Here, that alpha shows here, that alpha shows temperature coefficient. Clear? That alpha shows what? Temperature coefficient. Clear? Now, that means dr, that is the change in resistance equal to temperature coefficient into initial resistance into change of temperature is here. Okay, now we'll find the value of alpha. How to find the value of alpha? Now I have discussed here. Clear? Please note it. After that I will erase that thing. Clear? dr equal to what? dr equal to alpha into r naught dt is here. So I will erase. So dr equal to alpha into r naught dt. So at constant temperature, that means at initial temperature, the resistance becomes initial is there, that is R naught is here. If we increase the temperature, that means at a final temperature, the resistance becomes increases, that is represented as a final resistance. So if we put the limit, okay, then we get. So in order to integrate both of sides, integrating on both sides, so integration dr, that is from with proper limits. What is the limit? In order to increase the temperature, before increase of temperature at initial temperature, that is Ti, the resistance becomes initially present, that is R naught. So here at initial temperature T1, the resistance becomes what? R naught. Clear? At final temperature, while you increase the temperature T1 to T2, final temperature, at that case, the resistance becomes increases from initial resistance to final resistance, that is RF. Clear? So integration from initial resistance to final resistance, this is the limit of dr, and this is the integration from T1 to T2, that is the initial temperature, this is the final temperature. Here alpha R naught dt is here. So integration of dr means R, limit from R naught to RF, okay, equal to, this is alpha is temperature coefficient, that is constant quantity, R naught also constant quantity. Now integrate T1 to T2 dt is here. So that means upper limit minus lower limit. So RF minus R0 equal to what? Alpha into R naught. Here dt integration T from limit T1 to T2 is here. Clear? So that means RF minus R0 equal to alpha into R naught T2 minus T1 is here. So RF minus R0 equal to alpha into R0, that means T2 minus T1, that is final temperature minus initial temperature, that means change of temperature, that is denoted by del T. What? Del T. That is del T represent change of temperature, that is equal to T2 minus T1 represent as a del T. Okay, so here RF, that is the final resistance, equal to initial resistance plus alpha into initial resistance, del T is here. That means RF equal to R not taken in common, 1 plus alpha del T is here. Clear? So this is the final resistance, which is equal to initial resistance plus alpha del T. Or in order to find the temperature coefficient, so that we have represent a equation or an equation, we have represent an equation that is 1. So from equation 1, we have to calculate the value of alpha equal to RF minus R0 divided by here R0 del T is here. So this is the final expression of temperature coefficient alpha. That means final resistance minus initial resistance divided by initial resistance into change of temperature. That define temperature coefficient alpha. So what is the unit unit of temperature coefficient is here alpha equal to the Rf minus R0 means what? Resistance, that is the change in resistance, which is unit is ohm, divided initial resistance unit is ohm, and to change in temperature means its unit is what? Kelvin, okay, or centigrade. So ohm cancel out, so alpha equal to Kelvin inverse or centigrade inverse. So this is the unit of what? Temperature coefficient, Kelvin inverse or centigrade inverse. What? Kelvin inverse or centigrade inverse. Clear? Please note it. Then I will erase that thing. Now I have discussed about what is the temperature coefficient on semiconductor, what is the temperature coefficient in conductor, what is the temperature coefficient in alloys. Here in conductor we know alpha equal to what? Rf minus R0 divided by R0 into del T is here. As we know that in case of conductor, if you increase the temperature, that is temperature becomes increases, then resistance or resistivity becomes increases. You know that in case of conductor. So in order to increase of resistance, while you increase of temperature, that means here will happen alpha becomes positive. How it becomes positive? That means initial value should be less than that of final value, becomes while we increase the temperature, resistance becomes increases. Before increase of temperature, initial resistance becomes initial resistance, that is R0. While we increase of temperature, the resistance become final resistance, that should be more than that of initial resistance. So final resistance should be positive, while we difference that initial resistance, that's value always positive is here. So temperature coefficient always positive in case of semiconductor. In case of conductor, temperature coefficient always positive. In case of semiconductor, what will happen? Alpha becomes here in semiconductor temperature. If you increase the temperature, then resistance becomes decreases, as well as resistivity becomes decreases. So while we increase the temperature in case of semiconductor, the final resistance becomes decreases from initial resistance. That means the final resistance becomes decreases from the initial resistance, so its value, total value becomes negative. That's why whole term becomes negative. So alpha becomes negative. Clear? In case of semiconductor, the temperature coefficient becomes negative. This is the very important bit question for your board exams. Okay. So in case of conductor, alpha becomes positive because final resistance becomes more as compared to initial resistance. Total value becomes, the difference becomes positive. That's why it becomes positive. While we represent in case of semiconductor, the final resistance becomes decreases as compared to initial resistance. Therefore, their difference becomes as a negative value, so that the temperature coefficient also negative, because if you increase the temperature, then resistance as well as resistivity become decreases in case of semiconductor. That's why the temperature coefficient becomes negative. Are you getting my point? Next one is alloys. You know alloys. For example, which one is the alloy? Which are the alloys? That means Eureka, Constantan, manganese. These are the alloys. If we increase the temperature on that given alloys, then what will happen? Then resistance as well as resistivity, whose property could not be changed. That means there is no effect on the resistance as well as resistivity. So here we erase that resistance. So in case of alloy, in alloys, if we increase increase the temperature, then resistance as well as resistivity becomes unaffected. That means that remains constant. आमे जत्ते भी बढ़ेबा टेम्परेचर से माने कोन रहबे नियरली कांस्टेंट ही रहबे तो आमे भाबी देले कांस्टेंट बोली बा अनअफेक्टेड बोली भाबिले तेणु सो इट कोन होची देखो सो हमरो अल्फा कोन हबो अल्फा जतोल देखिबा द डिफरेंस बिटवीन व्हाट rf minus r0 so if you increase the temperature then there is no effect of resistance that's why that rf behaves as a initial resistance so r0 minus r0 rf represent as a r0 so r0 minus r0 whose whole value becomes 0 that means the difference becomes 0 that's why 0 divided by 0 r0 del t so the total torque represented as 0 so alpha becomes 0 so in case of alloy the temperature coefficient alpha becomes 0 because resistance as well as resistivity they do not affected by the temperature. Clear? Here please note it. In case of resistivity the temperature coefficient becomes, we know the formula Rf equal to R0 into 1 plus alpha del T is here. That Rf in the represent of rho, that is the resistivity. So Rf means, that means rho L by A. L represent as L2, A represent as A2, or that means length as well as area of excitation remains same. So rho into L by A, rho 1 into rho 2 into L by A, or rho F into L by A. Here R0 means rho initial into L by A, length as well as area of excitation remains same, into 1 plus alpha delta is here. So L by A cancel out. So rho F equal to what? Rho initial into 1 plus alpha del T. So this is the another expression in terms of resistivity. So this is the another expression in terms of resistivity. Okay. Or in other way we can define, that means what? The alpha equal to what? Rho F minus rho initial divided by rho initial into del T. So this is the final expression of temperature coefficient in terms of resistivity. Okay. So this is all about temperature coefficient on resistance as well as resistivity. Now I will discuss about some problems which are related to resistance as well as resistivity. Clear? Please note it. Here in problem number 1, the resistance of platinum wire is 10 ohm at ice point and 50 ohm at steam point. Find the temperature at which the resistance of wire is 60 ohm. That कौन देछि ice point माने कौन पिले ice केतबेले होछि 0 डिग्री सेल्सियस रे तमरो जल बाष्प केतबेले होछि steam point केतबेले कहबा 100 डिग्री सेल्सियस रे तार तो से दला the resistance of a platinum wire गोटे platinum wire को नबा ताको जदि हमें steam point रखिबा तारे तार resistance केतो होछि 50 ohm होछि steam point रे हला एट ice point रे केतो दिस वन इज ice point रे केतो होछि 10 ohm होछि तार तो गोटे platinum wire को नेले ताको ice point रखिले तार तो 0 डिग्री सेल्सियस रखिले से तार ओम केते ओम से रिप्रेजेंट करूछि त रेजिस्टेंस केते रहउछि 10 ओम रहउछि जतल ताको स्टीम पॉइंट को नउचे त रेजिस्टेंस केते होछि 50 ओम हे होछि ताले से फाइंड आउट करो जे को टेंपरेचर रखिले तार रेजिस्टेंस से प्लैटिनम वायर रो रेजिस्टेंस 60 ओम होबो ओके now I have to solve that thing. Okay, so given R1 equal to 50 ohm at ice point. That means T1 equal to 0 degree Celsius. Similarly R2, that is this is 10 ohm. R2 equal to 50 ohm at steam point. That means T2 equal to kete degree? 100 degree Celsius. Find R3 at find temperature. That means R3 is what? That is 60 ohm. That is 60 ohm at what temperature will पचारला T3 केते will पचारला. तो पिले हमें कौन करिबा रिलेशन करिबा फर्स्ट आउ थर्ड को नबा सेकंड आउ थर्ड को नबा ताको कंपेयर कर दवा जो दरे कि हम कोन मिलिबो टेंपरेचर ऑन द फाइनल रेजिस्टेंस ऑफ द प्लैटिनम वायर नो करि परिबा हला. So here from first and second condition, what? So formula कौन थिला पिले हमरो RF equal to R naught into 1 plus del T. Alpha del T is 0. So हम जतले फर्स्ट और सेकंड को देखिबा. So फर्स्ट और सेकंड रे फाइनल रेजिस्टेंस के 50 ओम, इनिशियल रेजिस्टेंस के 10 ओम, फाइनल टेंपरेचर कहते 100 डिग्री सेल्सियस, इनिशियल टेंपरेचर आइस पॉइंट कहते 0 डिग्री सेल्सियस. ओके, सो RF को हम कहते लिखिबा R2 लिखिबा. दैट मींस R2 इक्वल टू व्हाट? R2 इक्वल टू R1 into 1 plus alpha del T माने कौन लिखिबा? del T माने लिखिबा T2 minus T1. T2 minus T1. So R2 equal to R2 means 2 means कहते हैं R50 लिख दे परिबा. R कत लिख परिबा 50 लिख परिबा और जहां भी लिख परिबा R2 था. R2 equal to this one. Okay, so R2 माने कहते हैं R2 माने कहते हैं स्लाइटिंग. R2 असला तमरा 50 ओम equal to R1 माने कहते हैं 10 into 1 plus अल्फा को अल्फा रख ले. T2 माने कहते हैं 100 डिग्री minus T1 में कहते हैं 0 डिग्री. It's 0. So this is equation number 1. Similarly, from first and third condition हमें अप्लाई करिबा. फर्स्ट और थर्ड कंडीशन को जेतलो देखिबा कोन हबो पिले फाइनल रेजिस्टेंस इक्वल टू RF इक्वल हम कोन जानछे R naught into 1 plus alpha del T जानछे पिले. RF माने कहते हैं that implies RF हला तमरो R3. So R3 equal to R naught माने कहते हैं R1 into 1 plus alpha del T माने कहते पिले del T हला फाइनल टेंपरेचर T2 minus T1, sorry T3 minus T1. Clear? So it जेतलो हम रिप्रेजेंट करेबा that implies R3 माने कहते हैं R3 हला 60 ओम 60 equal to R1 कहते हैं 10 into माने चेन ब्रैकेट दो into 1 plus alpha into T3 माने कहते हैं T3 को हमें T3 कौन पचार से फाइंड आउट द टेंपरेचर को पचार से T3 को T3 रखिबा. T1 माने कहते हैं 0 डिग्री. Clear? So this is equation number 2. Please note it. Clear? Now dividing equation 2 by 1. Now dividing equation 2 by 1. Equation 2 divide करो 1 द्वारा. So कितना असला 60 by 50 equal to 10. Sorry, Which one is that? That is 10 divided by 10. 10 into what? 1 plus alpha T3 minus 0 degree divided by 1 plus alpha 100 degree 0. Clear? So that means 10 cancel, 0 0 cancel, 6 by 5 equal to 1 plus alpha cancel. What will it there? T3 divided by 100 is 0. That implies 6 into 100 divided by 5 equal to T3. That implies what will happen? T3 equal to 5, 20 is 100. That means T3 equal to 120 degrees Celsius. This is the approximately value is here. When T3 equal to, that means temperature, if you raise the temperature at about 120 degrees Celsius, then the resistance becomes 60 ohm. That means যদি আমি টেম্পরেচর को 120 ডিগ্রি বঢ়াইবা তাহলে আমি সে প্লাটিনম ওয়্যার रो रेजिस्टेंस केते पाइबा 60 ओम पाइबा. Please note it. Note it. Okay. My next question is the resistance of a heating element at a room temperature 27 degrees Celsius is 100 ohm. देखो ना गोटे हीटिंग एलिमेंट को रखले ताको रूम टेम्परेचर जतले रखले रूम टेम्परेचर केते 27 डिग्री सेल्सियस रखले से हीटिंग एलिमेंट रो रेजिस्टेंस हला 100 ओम. सो given at initial temperature T1 that is about 27 degrees Celsius, the initial resistance becomes Ri equal to 100 ohm. Clear? At what temperature? That means final temperature kete pachharse, that is T2 becomes question tag. Its resistance will be 134 ohm. So that the final resistance kete asche 134 ohm asche. So there is alpha equal to, that is temperature coefficient 1, alpha equal to 1.7 in 10 to the power minus 4 degrees centigrade inverse this. So as we know the formula, but that means final resistance equal to initial resistance into 1 plus temperature coefficient into change in temperature. This is the formula. So Rf this is divided by R0. Clear? Okay, equal to what? 1 plus alpha delta means T2 minus T1 is 0. That means what? That means here we can write Rf minus by R0 minus 1 equal to alpha into T2 minus T1. Clear? That implies Rf minus R0 divided by R0. Clear? Equal to alpha into T2 minus T1 is 0. Clear? So that you write what? That means Rf minus R0 means what? Rf what? The Rf means 134 minus R0 means 100 divided by R0 means 100 into that alpha which is going to denominator in left side. So that means alpha equal to T2 means what? T2 means T2 T1 means 27 degrees Celsius. 0. That implies, that means 34 divided by 100 into alpha means what? That means 1.7 into 10 to the power minus 4 equal to T2 minus 27 is 0. Clear? So here we can solve 34, that means 34 divided by 100 into 17 by 10. That 10 which is going to numerator, So its value is 10 to the power minus 5. 10 to the power minus 5 is here. Equal to T2 minus 27 degree. 27 degree. Clear? That means what? 34 divided by 100 and 10 to the power 10 to the power only minus 3 is there into 17 equal to 22 minus 27. So 17 2s are, that means 2 into 10 to the power minus 3 is going in numerator, then it behaves at 10 to the power 3. Clear? 10 to the power 3 equal to T2 minus 27 degree. That means 2000. 2000 here minus 27 is going to left side, that behaves as a 227. That is T2. That implies T2 equal to 2027 degree Celsius. So the final temperature of that given heating element is about 2027 degree Celsius, so that the resistance of the resistor or heating element is about 134 ohm. Clear? So I have solved two problems with some theoretical views, like as temperature coefficient on resistance as well as resistor, resistivity. Also I have discussed definition of resistance, resistivity, conductance and conductivity. So if any doubt, then ask me, okay, so that I have easily represent my theory in another way. So don't worry, please like and share my video to all. Thank you. Bye. Bye bye.